Now see a relation between cutoff potential and frequency of incident radiation falling on the metal plate and threshold frequency. We know Einstein's photoelectric equation, that is kinetic energy, that is maximum kinetic energy is equal to h nu minus h nu naught. Now we can write E v naught is equal to h nu minus h nu naught. So we can write V naught is equal to h by E nu minus nu naught. Now we can convert into the wavelength also the same equation. So we will be getting E v naught is equal to h c by lambda minus h c by lambda naught. So we can write here V naught is equal to h by E is into c 1 upon lambda minus 1 upon lambda naught. Now see, here nu naught is known as threshold frequency, nu is known as frequency of the incident radiation falling, lambda is the wavelength of the radiation falling on the metal surface, and lambda naught is the threshold wavelength. So this is the relation here, and here V naught is called the cutoff potential. We can also explain everything is with the help of the graph here. If you draw the graph between cutoff potential like this, and here like a V naught, and here is frequency. So the graph is obtained this. This point is known as threshold frequency. When we produce this graph, it goes and meet over here, that is the intercept. We know the relation E v naught is equal to, here we can write E v naught is equal to h nu minus h nu naught. So we can write V naught is equal to h by E nu minus h nu naught by E. So this one is actually representing, if you go for this y is equal to mx plus c. By comparing with this equation, this point is representing here, this is minus h nu naught by E. Now if you get it, see, you know the slope of the graph can be obtained from here, that is here delta V naught and delta nu. So now in this case we can write delta V by delta nu here. In this case we can take slope is equal to, this is h by E. So we can write here slope is equal to h by E. This is representing here the slope. So we can calculate the slope also from here, and from the slope we can calculate the value of h. So we can also write here delta V naught upon delta nu is equal to h by E. So h is equal to delta V naught, that is a stopping potential, upon delta nu into E. So we can use this graph also to calculate the slope, and from the slope we can define Planck's constant, the value of the Planck's constant. So we can get questions like this in board exam which are based on this graph.